Dear students, today in this lecture we will discuss about secant method for solving algebraic and transcendental equation. Okay. Secant method is very similar to method of false position or regular falsi method, and we will use the same formula as we use in method of false position or regular falsi method. Suppose this is the given algebraic or transcendental equation fx is equal to 0. Okay, first we locate the position of the root by calculating. Here because we are finding out the first positive root one by one from 0. We find out f0, f1, f2 and so on. Okay, till one value of one function must be positive and one function must be negative. Let us assume that f of x1 greater than 0 and f of x2 less than 0, or f of x1 less than 0 or and f of x2 greater than 0, or we can say that product of f of x1 into f of x2 less than 0 means first we locate the position of the first positive root. Okay, for the examination point of view we have to just find out first positive root of the equation. If the equation fx is of nth degree means it is having n root which may be real or imaginary, but here you have to find out only first positive root. Okay, first we apply the intermediate value property, and for this we locate the position of the root by calculating one by one f0, f1, f2 till one value we get positive and another is negative, or one negative and another is positive. Suppose here fx1 is greater than 0 or positive and fx2 less than 0 or negative, or suppose product of these two is less than 0. By the intermediate value property we can say that here there is at least one positive root between x1 and x2. Now we have to find out that positive root. Geometrically, how the secant method works: suppose this is x-axis, suppose this is y-axis, this is x dash, and suppose this is y dash. Suppose this is the given function. This is the given function y equal to fx. Okay. Sometimes it's given in the form of function, or sometimes it is given in the form of equation fx equal to 0. Suppose this is the point x1 and suppose this is the point x2. It is very much clear here. Coordinate of this point is x1 and f of x1, and coordinate of that point x2 and f of x2, and root is lies between by the intermediate value property. Value of function at one point is positive and value of function at one point is negative, means the curve crosses the x-axis. At this point, when curve crosses the x-axis, this point is called the exact root of this system of linear algebraic equation. This linear algebraic or transcendental equation. Okay. We have to find out this root. Here first we find out equation of chord joining these 2 points. Now we find equation of this line AB. First we find out equation of line AB. Line AB joining 2 points x1 fx1 and x2 fx2. Okay, what is the formula? Y minus y1, that is y minus fx1, fx2, y2 minus y1, fx2 minus fx1 upon x2 minus x1 and x minus x1. Okay, when on solving this, when this line AB crosses the x-axis, at that point y will be 0, because this is the first approximated root. When we put y equal to 0, what do we get here? When we put y equal to 0, we just cross multiplication, we get here x minus x1 equal to minus x2 fx1 plus x1 fx1 upon fx2 minus fx1. On solving this, we put y equal to 0, we cross multiply and we transform this term in denominator, we get this function. On solving this, we get x equal to x1 plus minus x2 f of x1 plus x1 f of x1 upon f of x2 minus f of x1. Okay, that is x equal to f of x2 minus f of x1. Here we have x1 f of x2 minus x1 f of x1 minus x2 f of x1 plus x1 f of x1. Now these two are cancelled out. We get x is equal to x1 f of x2 minus x2 f of x1 upon f of x2 minus f of x1. Okay, and this is called the first approximated root. That is, we can say this is first approximated root x dash, or we can say this is equal to x3. Okay, now we find out first approximated root. Okay, next we find out value of function at this point. Okay, and means now we have this point C, and coordinate of this point is x3 and fx3, and we apply the same formula. Again we find out equation of chord joining these 2 points, and we can get here next approximated root. Now we apply without using intermediate value property. Here in secant method you have to apply intermediate value property. You have to check intermediate value property first time. First you have to locate the position of that root, and second time no need to apply intermediate value property, whether the root lies between x1 x2 or x2 x3 or not. Now next we calculate x4. Formula is x2 fx3 minus x3 fx2 upon fx3 minus fx2. Next we find out value of function at this point again. Next we calculate third approximated root, that is value of x5. We have the formula x3 f of x4 minus x4 f of x3 upon f of x4 minus f of x3. Okay, means similar fashion we can find out nth approximated root. Okay, that is we can get here n plus 2, or we can write here xn f n plus 1 minus xn plus 1 fxn upon f xn plus 1 minus fxn, and this procedure is repeated till the difference of two consecutive approximation is negligible or zero. This is repeated till the difference of last two approximation, last or second last approximation or approximated values are difference of last two are negligible or zero. Okay, this whole procedure is called secant method, and it's a slower method. Its rate of convergence is 1.618, and while when we next method, when we use next method, Newton-Raphson method, it's a faster method, and its rate of convergence is 2. Okay, now we will try to understand this problem with the help of this method, with the help of one example. We have a problem. Find a real root. Question is of the equation x cube minus 2x minus 5 equal to 0 by using secant method. Correct to 3 places of decimal. Okay. Here given function, given equation is x cube minus 2x minus 5. Okay, first we locate the position of the root by calculating one by one these value till we get one positive and one negative. We get f0 is minus 5 negative value, f1 is 1 minus 2 minus 5, that is minus 6 again negative. f2 is 8 minus 4 minus 5 means this is equal to minus 1 again negative. Next we find out f3 means 27 minus 6 minus 5 means this is 16. Okay, negative 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 positive means sign changes, function value of function is changes, negative to positive means root is lies between this 2 and 3. By the intermediate value property we can say if at the point 2 function is negative and at the point x equal to 3 function is positive, means the curve crosses the x-axis between these 2 points 2 and 3. Okay, means the first positive root lies between 2 and 3. Okay, here f of 2 into f of 3 less than 0. By the intermediate value property we can say there is at least one positive root between 2 and 3. Let us suppose that x1 is equal to 2, f of x1 is equal to minus 1, x2 is equal to 3 and f of x2 equal to 16. Now we apply secant method. We calculate first approximated root. Here first approximated root formula is h dash, formula means suppose it is equal to x3, x1 fx2 minus x2 fx1 upon f of x2 minus f of x1, that is x1 means 2 into 16 minus plus 3 into 1 upon 16 plus 1. What is the first approximated root? That is x dash equal to x3 is equal to, this is 35 upon 17 and it is 2.0588235 approximately. Okay, if your answer is correct up to the second or third places of decimal, if your as per your calculation, after calculation, okay, If you get some different terms in last 3-4 terms, means this is due to the limitation of your calculator. It should be correct minimum up to the second or third places of decimal. Okay, this is the first approximated value. Now we find out value of function at this point. Next we find out f of x dash or f of x3 or f of 2.0588235. Okay, what is the value of function at this point? When we calculate this with the help of calculator, we get here 390799, and which is less than 0. Next we calculate second approximated root. x4, that is formula is x2 f of x3 minus x3 f of x2 upon f of x3 minus f of x2. We have to apply this formula whether the root is whether we have root between two x2 and x3 or not. In regular falsi method, again we have to locate the position of the root, whether the root lies between x3 and x1 or x2 and x3. But here no need to check again and again whether the location of that root. x2, what we get here? x double dash x4 equal to x2. x2, what is the value of x2? Means x2 is 3 into f of x3. f of x3 is minus 0.390799 minus x3. x3 is 2.0588235 into f of x2. f of x2 is 16. This is f of x2, 16 upon f of x2. f of x3 means 0.390799 minus 16, and when we calculate this with the help of calculator, we get here 2.0812635. This is the first approximated root, and this is the value of second approximated root, which is constant up to the first places of decimal. Means we have to take more steps for getting better accuracy. Now we calculate value of function at this point. f x double dash, that is f x4, that is f at the point 2.0812635 with the help of given relation. On solving this, we get here minus 0.1472062. You can calculate this with the help of calculator. Okay, because all the numerical methods are computer oriented method. But basically these methods are designed for the programming purposes. We can develop a program, and we have to solve this with the help of computer. Next we calculate the third approximated root, x triple dash, that is x5. Formula is x3 fx4 minus x4 fx3 upon fx4 minus fx3. What is the value of x3? x3 is, we can write here, x3 is x triple dash equal to x5 and x3. What is the x3? x3 is 2.05 2.05235 into fx4. What is the value of function at this point? It is minus 0.1472062 minus x4. What is x4? x4 is 2.0. This is the value of x4, 2.0812635 into f of x3. What is the value of function? It is minus 390,799. Okay, upon f of x4 minus f of x3. Here f of x4 is minus 0.1472062 and minus plus, here we get 0.390,799. On solving this, we get third approximated root, which is equal to 2.0948242 approximately. Okay, next we have to find out value of function at this point. This is the third approximated root. This is the first approximated root. This is first approximated root. This is the second approximated root, and this is the third approximated root. Okay, next we have to find out value of function at this point, that is value of f of x5, that is value at the point 2.0948242. What we get here when we find out value of function at this point? We get here 0.0030447. Okay, now we calculate next approximated root, that is next we calculate x4, that is x6, and formula is x4 f of x5 minus x5 f of x4 upon f of x5 minus f of x4, that is fourth approximated root, or x is equal to x4. What is x4 here? x4 is 2. This is x4, 2.0812635 into f of x5. f of x5 is this value, 0.0030447 minus x5. What is x5? x5 is 2. This is x5, 2.0948242 into f of x4. Value of f of x4 is this, minus 0.1472062. Okay, this is the value of f of x4 upon f of x5. What is f of x5? 0.0030447 minus f of function की value of function at this point, f of x4 means 2.0812635. it is minus plus, we get here 0.1472062. okay, and here we get positive value. On solving this, what we get on solving this? x6, here we get x6 is equal to 2.09 45494. Now where we can stop this procedure, it is we can find out the difference of last two. It is 2.094 and it is 2.0945, and after rounding out this is 2.095. Means if we take one more step, then we can get more better solution. Next we find out value of function at this point. What is the value of function at this point? So this is 0.0023. Okay, and we calculate next approximated root, that is x7. Formula is x5 fx6 minus x5 fx6 minus x6 fx5 upon fx6 minus f of 5. What we get here? x5 is, what is x5? x5, this previous one, 2.0948242, 2.0948242 into f of x6. F of x6 means this value minus 0.40 and 232 minus x6. What is x6? x6 is this value is x6. It is 2.0945494 into f of x5 means this value. This is 0.00304447 upon f of x6. F of x is minus 0.40232 minus f of x5. F of x5 is 0.003047. On solving this, we get here fifth approximated root, that is